Hello and welcome back to Python. In this video, I will show how to perform matrix operations in Python. So for this, we have to import the library called NumPy. Import NumPy or NumPy as input. We all know how to initialize the matrix. I'll give an example for the initialization. Let us suppose the matrix is called M1, and N1 is equal to MP dot array of, within the square brackets, right, 1, 2, and again take this second row as 3, 4. Now if you print this one, you get a matrix. So 1, 2, 3, 4 is a matrix. First, I'll show how to access rows of a matrix. So accessing rows of a matrix. So to access the rows, you can use print option, print of the matrix M1. And in the above matrix, we have only 2 rows. This is called row 0 and this is called row 1. So first we'll access row 0. And then later we'll go with the row 1. M1 of 1. So first one is a 0th row, second one is called first row. So this is how we can access the rows of a matrix. Similarly, we can access columns of the matrix. So how to access the columns? So I just want to print the columns from the beginning, M1, put the colon, comma, 0. So the first column. So the first column is 1 and 3. The second column is 2, 4. I want to print the second column. Then print M1 of the column. From the starting is column -1. To the end, we have tried as -1. So it will print 2, 4. So the second column. So this is how we can access rows and columns of the matrix. Now we'll find the product, that is a matrix multiplication. So we all know for matrix multiplication, the number of columns in the first matrix should be equal to number of rows in the second matrix. So we'll take 2 matrices. M1, we already have one matrix, we can take this. And then we'll take one more matrix as M2. And please do remember the columns, the number of columns of the first matrix should be same as number of rows in the second matrix. So now we'll modify these values. 3, 2, 4, 5, and 4. Okay. Now to perform the multiplication, we consider a variable x is equal to M1 dot of, dot is a function of the matrix M2. Now we'll print the final matrix, print X. So this is the for the matrix multiplication. So this is the first function. Now we can find the transpose of a matrix. Transpose is nothing but switching rows with its columns. Now take matrix M1. Now use the variable x is equal to M1. Now we have a function called transpose. Transpose of M1. So now it finds the transpose. You can print both M1 and X1 so that we'll understand the difference between the original matrix and the transpose of matrix. X. So original matrix is 1, 2, 3, 4. Now the rows have become the columns. So 1, 2 is a row and here it has become column. Similarly, 3, 4 is a row and it has become as the column. So that is called transpose. Now we'll find the inverse of a matrix. So consider the matrix. Now to find the inverse, we'll take a variable again x is equal to and use the function np dot linear algebra. I told you NumPy linear algebra provides the functions for the matrix operations. Algebra dot inverse of M1. So print x. So it finds the inverse and then gives the result. So we have to use the function, and from NumPy from the linear algebra library, from NumPy linear algebra, we have to import this function called inverse. See, in the previous case, we can use the function directly, but this inverse function is provided in NumPy linear algebra. Okay, that is inverse. Similarly, determinant is also the same. Instead of inverse, you can find the determinant of the matrix. So for that, again, we have to use the same library, NumPy linear algebra. And for determinant, we have a function called det. Determinant, you know, AD minus BC. So it gives the determinant of the matrix. And also we can find the inner product of the matrix. Inner product is multiplying corresponding elements and adding up all those products. So to find the inner product, we have to take equal size arrays, and after the inner product, we get the result in scalar form. So for that, we can take two matrices M1, M2. So consider these two matrices M1 and M2. Now print inner product of these two matrices. Print np dot, there is a function called inner product of M1 comma M2. So I have taken two arrays of equal size. So the inner product multiplies the corresponding elements and adds up all those products and returns a scalar. So np dot inner of n1 comma n2. Now if we see the difference between the multiplication and the value here, the multiplication and the inner product, they are quite different, right? So these are the matrix operations, simple matrix operations. So first we have to import NumPy library, then initialize the matrix. How to initialize the matrix? Take a variable and write np dot array of, give how many number of rows and columns you want, 2 by 2 matrix or 3 by 3 matrix, initialize it. First print the matrix to see whether we have initialized the matrix properly. We can have a 1-dimensional, 0, 2-dimensional and 3-dimensional matrices arrays, and then we can have 2 by 2, 3 by 2 by 3 dimensions m by n matrix. And then to access rows of the matrix, you can use the indexing m1 of 0, then m1 of 1 half. So the first always will be the 0th row, second will be the next will be the first row, 2, 3, and so on. So that is how you access the rows of a matrix. And to access the column of the matrix, we have to use colon, comma. So if you want to go from the beginning, go with the 0. And if you want the n, go with -1. This is how we have to print the columns of matrix. And for the matrix multiplication, initialize two matrices, that is two arrays M1 and M2, and use the function called dot, M1 dot of M2. Then it gives the matrix multiplication. One thing you have to remember is the number of rows of the columns of the first matrix should be equal to the number of rows in the second matrix. Generally, you can perform matrix multiplication. That is the basic rule for the matrix multiplication that you have to follow. Next is to find the transpose of the matrix. In Python, in NumPy library, we have transpose function. Just to take the matrix and then use a method called transpose M1 dot transpose. Then to find the inverse of the matrix, you have to use NumPy linear algebra. I told you this provides different functions such as dot, inner product, determinant, and inverse. So for that, you have to write np dot linear algebra linalg dot inverse of the matrix M1. Then we'll get the inverse of the matrix. Similarly, to get the determinant, we can use dot det of M1. And then to find the inner product of two matrices, we can use directly np dot inner of M1 power M2. I hope you all understood the matrix operations. Thank you.